Hello, welcome to Maitri Vidya YouTube channel. So in this video we are going to discuss equation of the tangent to the circle when a point is given. Okay. So as we know that the point position of a point with respect to a circle can be, so the point can be lie on outside the circle, the point can lie on the circle, the point can lie inside the circle. So we have three cases here. So whenever the point lies outside the circle, so if a point is given outside the circle, so is a tangent is possible. So we are going to find the equation of the tangent. So whenever the point is given on the circle, so we are going to discuss whether the tangent is possible. So if it is possible, what is the equation of the tangent? So after that, if the point is given inside the circle, so we are going to find the we are going to discuss whether the tangent is possible or not. So if it is possible, so we are going to find the equation of the tangent. So first let me take the point lies outside the circle. So that is the case first I have taken. So as you observe here, the point is given outside the circle. A circle is given. So can we draw a tangent passing through this point, okay, to this circle? So through a given point, I can draw so many infinitely many number of straight lines passing through this point. So those straight lines can be in this way. So actually I have selected this orange colored line. So if you observe this orange colored line, so I'm rotating this orange colored line. So these are the all possible cases. So cases of straight lines passing through this point, given point. So I can draw infinitely many number of straight lines. So, but out of all these straight lines, so two straight lines, the blue colored lines here, so they are the tangents. So if you observe, so the orange colored line, it is exactly coinciding with the blue colored line at this place once and at this place once. So these two are the tangents. So now from the diagram we can understand that from a given point external to the circle, okay, so we can draw two tangents. One is this and another one is this to a given circle. So that is the conclusion I have got here. So now I understood that I can draw two tangents from an external point to the circle. So now I am going to discuss what are the equation of the tangents. So whenever the circle equation and point is given. So let me assume that equation of the circle is s is equal to 0 and a given point is x1 comma y1. So s is equal to 0 means from the notations, if you don't know the notation, what is the meaning of s and s1 and s11, s12, okay, you can check the previous video discussing the notations. So for me, for this video, just I'm writing the s is equal to 0. So for this s is equal to 0 circle, point is given. So let us assume that this point lies outside the circle. So the equation of tangents, okay. So I can draw the pair of tangents equation, okay. Pair of pair of tangents equation will be s1 square is equal to s into s11. So this is one way to find the equation of the tangents. So the other way can be the traditional way always we can apply the r is equal to d condition. R is equal to d means the radius of the circle. should be equal to distance from center. Distance from, so this is the condition, a straight line to be a tangent. So I can always apply this condition to find the equation of the tangents. So now if you observe, I can I need a equation of straight line basically. So I have a point here p x1 comma y1. So all I need is the slope of the straight line, which should be a tangent to this circle. Uh, so let me assume that the tangent equation. Let me assume that. Let us assume tangent is y minus y1 is equal to m times of x minus x1. So this is the equation of the straight line passing through the point x1 comma y1 and having the slope m. Okay. So now I know the value of x1 y1, so that will be given. So I don't know the value of m. So to find the value of m, so I'm going to apply the condition. So radius of the circle is equal to distance from the center of the circle to the straight line. So if I apply that condition, I'm going to get the value of m. So through that value, if I get that value, so I'm going to uh, get the equation of the tangent. So now what we will do is we will take a problem, example problem. So to understand this concept in a better manner, so we are going to solve the problem. So with the help of S1 square is equal to S into S11 formula, that is a pair of tangents equation, and we are going to find the equation of tangents. So by applying this condition, so we are going to check whether they are same or not, whether the answer is same or not. So let me take a problem. Find the equation of the tangent. Passing through 2 comma 1 point to the circle x square plus y square is equal to 1. So equation of pair of tangents is, I know that is s1 square is equal to s into s11. Okay. So let me write the equation of the circle here. So the equation of the circle is x square plus y square. So transpose this 1 to the left hand side. So we're going to get minus 1 is equal to 0. So the left hand side part, that highlighted part is S. Okay. So I'm going to write the S1 and S11 for this. So with the help of this S, I'm going to write the S1 and S11 also. And one more thing, the given information. So the point is given as 1 comma So here, so the 1 is x1 and the 2 is y1. So that is the given values. So now if you observe, I'm writing the s1 square is equal to s into s11. Okay. So s1 means, so x square we have, x square can be splitted as, can be written as x into x1 plus y square can be written as y into y1 minus 1. So for that, whole square is there. So that is s1 square, okay, is equal to s. We have to write this expression as it is once again. So that is x square plus y square minus 1 times s double 1. So s double 1 means substituting the x1 y1, so in the place of x and y in this expression. So we are going to get x1 square plus y1 square minus 1. So in the place of x1 y1 I am going to substitute 1 and 2. Okay. So why? Because the x1 y1 values are given here. So substitute x into 1 plus y into 2. No, no. So I have mistaken here. The point is 2 comma 1. Okay, I have taken it as 1 comma 2. Let me fix that. So that is a 2 comma 1. Okay. So now in the place of x1 I have to substitute 2, and in the place of y1 I have to substitute 1 minus 1. So whole square is equal to, so it will be x square plus y square minus 1 into x1 square means that will be 2 square plus y1 square means it will be 1 square minus 1. So now if you observe, 1 square value is 1, so plus 1 minus 1 gets cancelled, 2 square value will be 4. 4 will be multiplied to this expression x square plus y square minus 1. So on the left hand side, 2x plus y minus 1 whole square is there. So this can be expanded according to the formula a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So now if you observe, so the a value here is 2x, b value here is y, c value is minus 1. Okay. So whenever the we have the c involvement, so we are going to get that term as a negative term. Why? Because the c value is minus 1. So if I expand this, so what I'm going to get is a square. That means 2x square. It will be 4x square plus b square. B square means that will be y square plus c square. C square means minus 1 whole square. Minus 1 whole square value is plus 1 plus 2ab. 2 times of 2x, that is 4x times of y. So that will be 4xy. So we have a 2bc term. So there is a involvement of minus 1 here. That is why I put minus sign here. 2 into 2x, that will be 4x times of minus 1. Okay. So 4x minus 4x. So it will be minus 4x and 2ca. 2 into, so that is not 2bc, actually it is 2ca. Now I am writing the 2bc. 2 into y into minus 1. So that will be minus 2y is equal to. So here I have so the left hand part is completed. Now the right hand part I'm writing. So 2 square value, 2 square times of x square plus y square minus 1. 2 square value is 4. 4 times of x square, 4x square. So 4 times of y square, 4 y square minus 4 times of 1, 4. So 4x square on the right hand side, 4x square on the left hand side, they get cancelled. So y square on the left hand side, and we have the plus 4y square on the right hand side. So if you transpose 4y square onto the left hand side, it will be minus 4y square. Y square minus 4y square, it will be minus 3y square. Okay, let me write y square term. So that is minus 3y square on the left hand side. So there is no xy term on the right hand side, only the left hand term is there. That is 4xy. The x terms, okay, only one x term, that is minus 4x, and y term, that is 2y. And here we have the plus 1, and we have minus 4 here. Minus 4 is can be transposed to the left hand side. So we are going to get plus 4, plus 1 plus 4, it will be plus 5 on the left hand side. So this is the equation of pair of tangents. Okay, so that means both the tangents to the circle, so they lie uh, equation of the tangents, so which can be drawn from a point which is lying outside the circle. So this is the equation of the pair of tangents. So let me cross check this answer. So with the help of the uh, traditional method, okay, that is radius of the circle is equal to distance from the center of the circle. So let me assume that equation of tangent is equation of tangent is y minus y1 is equal to m into x minus x1. Okay, so the x1 y1 value here is x1 comma y1 is equal to 2 comma 1, that is a given. So the equation of tangent can be written as y minus y1 value is the y coordinate, so the value will be 1 is equal to m into x minus, so the x1 value is 2. So let us simplify this equation. M can be multiplied to the expression x minus 2, mx minus 2 times of m, that will be 2m. So y minus 1 on the left hand side. So transpose all the terms to one side. It can be written as mx minus y plus 1 minus 2m is equal to 0. So this is the equation of the tangent we are going to get. So with the slope m. So for this tangent, I am going to apply the condition radius is equal to distance from the center. So this is the condition I am going to apply. So distance from here, the distance is distance from the center of the circle. So as we observe here, equation of the circle is x square plus y square is equal to 1. So it is in the format of x square plus y square is equal to r square. So the radius of the circle is r is equal to 1. Okay. So the r value here is 1. So 1 is equal to, so the distance, I am writing the distance formula here. So mod of, substitute the coordinates in the place of x and y. So from which we are finding the distance to the straight line. So M is there. So we are finding the distance from the origin. Why? Because the center of the circle x square plus y square minus 1 is equal to 0 is 0 comma 0. The center of the circle is 0 comma 0. I am substituting 0 in the place of x and 0 in the place of y plus 1 minus 2m whole divided by under root of x coefficient, that is m square plus y coefficient is minus 1 whole square. So now we have got an equation in m. We have to solve for m in this equation. So let me simplify this. If you transpose this denominator to the left hand side, so I'm going to get under root of m square plus 1. So on the left hand side it will be 0 0 and 1 minus 2m. So 1 minus 2m mod. So what I will do is I will square on both sides. Okay, I will square on both sides. So the square and square root gets cancelled on the left hand side. So on the right hand side 1 minus 2m whole square. So it is in the format of a minus b whole square formula. So I'm going to expand that. So now on the left hand side we have m square plus 1, which is equal to 1 minus 2m whole square. 1 minus 2m whole square value is 1 square, that is 1, minus 2m whole square value is 4m square. So 2 into 2m into 1. So that will be minus 4m on the right hand side. So the 1 and 1 they get cancelled. So the m square, if it's transposed to the right hand side, it will be minus m square. So 4m square minus 4 m square value will be 3m square. So 3m square I'm writing 3m square minus 4m. So which is equal to 0. So this is a quadratic equation. We have to solve the quadratic equation. So as we observe this quadratic equation, so it's a simple quadratic equation. So I can take m common from both the terms. Okay. So I'm solving the quadratic. So if I take m common, so m into 3m will be left here minus 4 is equal to 0. Okay. So now what we have to do is, so from this we can get the values of m. So m is equal to either 0 or m is equal to 4 by 3. So substitute, we are going to, we got the two values of m corresponding to the two tangents. So we are going to substitute these values of m into the equation, y minus 1 is equal to m times of x minus. So in the place of m, you substitute 0 for one condition. So I'm going to substitute the m value 0. Y minus 1 is equal to m into. So that is 0 into x minus 2. So we are going to get y minus 1 is equal to 0. This is equation of one tangent. So other tangent will be y minus 1 is equal to m value is 4 by 3 into x minus 2. Okay. So now what we have to do, let me simplify this equation. So 3 is transposed to the left hand side, 3y minus 3. 3y minus 3 is equal to, multiply 4 to the expression x minus 2. We are going to get 4x minus 8. 4x minus 8. So if I rearrange the terms, 4x minus 3y minus 3 comes to the left hand side, it will become plus 3. Minus 8 plus 3 value is plus sorry, minus 5 is equal to 0. This is the equation of the second tangent. So now if you observe, we got the two individual tangents. So in the previous discussion, so we got the pair of tangents equation. So now what I'm going to do is I'm going to multiply these two expressions, that is y minus 1 and 4x minus 3y minus 5. Okay, so let me so I'm going to check whether the both the answers are same or not. Pair of straight lines line will pair of straight lines equation will be y minus 1 times of y minus 1 times of 4x minus 3y minus 5 is equal to 0. Multiply for I to the entire expression. So that will be 4xy minus 3y square. Y times of minus 5, that will be minus 5y. So minus 1 into 4x, that will be minus 4x. Minus 1 into plus 3y, minus 3y, that will be plus 3y. So minus into minus, that will be plus 1 into 5, that will be 5 is equal to 0. So this is 4xy minus 3y square minus 5y plus 3y, it will be minus 2y minus 4x plus 5 is equal to 0. So if you observe this equation and the equation from the formula we have got, okay, so they both are same. So let us assume that I use the formula s1 square is equal to s into s11 to find the equation of the tangents. So in this case, I am going to get the pair of tangents. So if I want to find the uh, instead of finding the pair of tangents, so if I want to find the individual tangent equation, so from this pair of tangent equations, so can I get the equation of the tangents? So there is a technique in the pair of straight lines concept. So let me write the pair of tangents equation here. Okay, so now what I'm doing is I'm trying to find the individual tangents equations from the pair of tangents equation. So let us assume that we didn't use the condition r is equal to d, but if I have used the equation of pair of tangents, that is s1 square is equal to s into s11. So I'm going to end up with this kind of equation, that is a pair of straight line equation. So from the pair of straight line equation, can I find the individual straight lines? Okay, so that is what I'm going to do now. So now take this highlighted part, so make an equation. This highlighted part, it is called second degree part in the pair of straight line equations. Why? Because so the degree of this term, so the degree of x is 1, degree of y is 1. So the put together, so the degree of 4xy is 2 and degree of this term is 2. Why? Because the power of y here is 2. So for the remaining terms, the degree here is 1, the degree for 4x is 1. So the degree for this constant term is 0. So I'm just highlighted uh, the part so in which the term has a second degree. Okay, so the second degree terms were highlighted here. So now I have to make an equation with the second degree terms. So that equation is 4xy minus 3y square is equal to 0. Okay, so what this equation 4xy minus 3y square is equal to 0 represents means, so it is going to represent so the equation of pair of lines passing through the origin and parallel to this given pair of straight lines. So what is the meaning of that is, so if I take a coordinate axis in this way. So if I have two straight lines somewhere else here, okay, so I'm drawing one straight line here and one more straight line here. So these are the pair of straight lines we have. So this second degree part of this equation, so I have used the second degree parts from this pair of straight line equation to form a new equation. So this equation will represent the pair of straight lines, so passing through the origin and parallel to the given pair of straight lines. So what is the meaning of that is, so if I move, if I move, if I move this straight line parallelly, and if I make this passing through the origin, okay, and if I move this straight line parallelly, and if I move in this way, okay, these are the straight lines I'm going to get passing through the origin. So that means these straight lines pair of straight lines equation can be represented with the second degree uh, terms in the given pair of straight line equation. So with the help of second degree terms in the given straight line equation, so we can frame the pair of straight lines equations passing through the origin and which are given. So which are given. So let me take, and so these are the given pair of straight lines. So the given pair of straight lines equation is this equation. Okay. So these are the straight lines passing through the origin but parallel to this given pair of straight lines. So that equation will be given by this. Okay. So that is the meaning of this 4xy minus 3y square is equal to 0. So now this is a quadratic in y. Okay. So what we have to do is we have to factorize this expression. So how I am factorizing this? I can take y common from this. So y times of 4x minus 3y. So that means one straight line equation is y is equal to 0. Another straight line equation is 4x minus 3y is equal to 0. So these two are the straight lines which are passing through the uh, origin and as well as parallel to the given pair of straight lines equations. So as we know that, okay, if this expression, the straight line equation passing through the origin is ax plus by is equal to 0. Since we don't since it is passing through the origin, so we will not be having the constant term here, so that is why I didn't write the plus c. Okay, so this equation can be written as ax plus by plus c1 is equal to 0. Why? Because two parallel lines, so they are only differed in the constant term. Okay, so the concept and that concept I'm using here. So these pair of straight lines can be in this format. Okay, so let me write the pair of straight lines uh, from uh, from this equation. Actually, this can be written as y plus c1 is equal to 0. I'm assuming in that way. So let us assume that the pair of straight lines representing this equation is y plus c1 is equal to 0, and another one is 4x minus 3y plus C2 is equal to 0. Why? Because y plus C1, y plus C1 is parallel to the y is equal to 0, and 4x minus 3y plus C2 is equal to 0. It is parallel to the 4x minus 3y is equal to 0. So now what I'm going to do is I'm going to multiply this expression to this expression. So that is the meaning of pair of straight line equation. So let me do that. So y plus 1, y plus C1 times of 4x minus 3y plus C2 is equal to 0. So now it multiply term by term. So we are going to get 4x y into 4x 4xy. So y into 3y, that will be minus 3y square plus y into c2, that will be c2y, and c1 into 4x, that will be plus 4c1x, c1 into minus 3y, so that will be minus 3c1y, and c1 into c2, that will be c1 c2 is equal to 0. Okay, so now pair of straight line equation is 4xy minus 3y square minus 2y minus 4x plus 5 is equal to 0. So let me highlight this part, the y part. The coefficient of y here is minus 2. So the coefficient of y here is plus c2 minus 3c1. Okay. So let me write that. So by comparing the coefficients of y, so they are going to be the same. Why? Because the pair of straight lines, I've assumed it as y plus c1 is equal to 0, 4x minus 3y plus c2 is equal to 0. So this pair of straight line is going to represent this given above equation. So that is why I'm comparing these two equations. So by comparing the y coefficients, so I will get c2 minus 3 times of c1. So that should be equal to minus 2. So that is the one comparison. I can compare the x coefficient also. So there is only one x term here. Let me highlight that. So that is 4c1. So that will be equated to the minus 4. So now what I'm going to get is 4c1 value. 4c1 is equal to, so x coefficient from the above equation, that will be minus 4. So now if I observe 4c1 is equal to minus 4 means, so the c1 value will be minus 1. Substitute this c1 value minus 1 into this equation. So c2 minus 3 times of minus 1 is equal to minus 2. So this will be plus 3. Plus 3 is transposed to the left hand side. We are going to, sorry, right hand side. We are going to get minus 3. Minus 3 minus 2, it will be minus 5. So c2 value is equal to minus 5. So the only the unknowns here is c1 and c2. We got the values of c1 and c2. Substitute in the place of c1. In the place of c1, substitute minus 1. Okay. And in the place of c2, substitute minus 5. Okay. So we are going to get the equation of the dynamics. So what I'm going to do, I'm writing here y plus c1 value is minus 1. So it will be y minus 1 equal to 0. That is one straight line equation. So that is one tangent equation. The another tangent will be 4x minus 3y plus c2. So c2 value is minus 5 equal to 0. So what I'm trying to say here is, so if you use the formula, s1 square is equal to s into s11, So we are going to get the equation of pair of tangents equation. So we can from the pair of tangents equation, so by factorizing the homogenization part and adding the constant to the factors, and we can get a pair of straight line equation, and comparing the pair of straight line equations. So with the given pair of straight line equation and the assumed pair of straight line equation, so we can split this pair of straight line equation into the two individual straight line equations. So in this way we can do. So on the other way, so by assuming the equation of the tangent as y minus y1 is equal to m into x minus x1. So we can get the equation of tangents, individual equation of tangents very neatly. So that is what I am going to conclude from this discussion. So up to so far we have discussed equation of tangent to a circle from an external point to the given circle. So now we are going to discuss equation of tangents if a point is lies on the circle. Okay, equation of tangents if a point lies on the circle. So this is the case when a point lies on the circle. So I have given a circle here. So I have given a straight line. Actually, let me select this straight line. Okay, so from this given point, I can draw so many tangents in this way. Okay, so all are passing through the same point. Okay, so out of all this, so in this position, the straight line is intersecting the circle. We can say that it's a secant line. It's a secant line in this position. It's a secant line. It's a secant line in this position also. So at only one place, at this place, it is going to be the tangent to the circle. So if a given circle equation is s is equal to 0 and given point is x1 comma y1, so we can say that equation of tangent is s1 is equal to 0. How I got this conclusion is, so from the previous discussion, pair of tangents equation is s1 square is equal to s into s11. So since the point lies on the circle, the s11 value here is 0. Okay, so this will become 0. This will become 0. So s into 0, it will be 0. So we are going to get s1 square is equal to 0. S1 square is equal to 0 means, so that value will be S1 is equal to, so 0. So since the point lies on the circle, so it is going to satisfy the circle equation, that is S is equal to 0. That is why S11 value will be 0. So 0 times of S, that will be 0. So that is how I got the conclusion that equation of the tangent is S1 is equal to 0. Okay. So this is the equation of the tangent whenever the point lies on the circle. So now what I have to do is, I'm going to discuss one more condition whenever the point lies inside the circle. So here one point is given inside a circle. So through this point I can draw infinitely many number of straight lines. So let me show that. So this is the straight line passing through this point. If I rotate this straight line, okay, in this way, so these are the all different possible straight lines passing through a given point. So no straight line, okay, no straight line, it is becoming tangent. Okay, so it is definitely it has to definitely intersect the circle. Okay, so whenever the point lies inside the circle, so we can say that no tangent is possible. No tangent. No tangent is positive. So now, how to find the point lies inside the circle means? So we have to find the S11 value. S11 value. So it will be less than 0 for the point lies inside the circle. So if we have the S11 is less than 0, we can say that uh, there is no tangent possible to the given circle through a given point. So now, so from this discussion, what I want to conclude is, so whenever a circle equation is given and point is given, first what we have to do is we have to find the S11 value. So if we find the S11 value, so if we are going to get it as positive, so we can draw a conclusion that the point lies outside. We can draw a conclusion that point lies outside the circle, and we can follow this procedure to find the equation of the tangent. So if the S11 value is equal to 0, we can draw a conclusion that the point lies on the circle. So the equation of tangent will be S1 is equal to 0. So if the S11 value is less than 0, so we can draw a conclusion that the point lies inside the circle. So we can say that there is no tangent possible. So that is the equation of tangents. So now I want to discuss one more concept here. So the length of tangent. So the length of tangent. The concept here is, what is the length of tangent? So if you observe from an external point, so if we draw a tangent to the circle, it will touch the tangent at one point. So let me name that point as A. Okay. So this point is A. So from the given point, if I find the distance from the given point to the point of contact, so the PA distance is called as length of tangent. PA distance is called as length of tangent. So the length of tangent is given by the formula under root S11. Under root S11. So that is the PA length. Actually, we will be having one more point at the point of contact here. So that is P. If I assume that point as B, so the PB distance is also same. Okay. Why? Because circle is a symmetric structure. Okay. So PA and PB distance will be the same. So we are going to call PA and PB, both the PA distance and PB distance, as length of tangent. So their values will be same, and it will be equal to under root of S11. So that is the length of tangent. So let me discuss one more problem for this concept. Equation of tangent whenever the point lies on the circle. Okay. So now let me write the question. Find the equation of the tangent to the circle x square plus y square is equal to 1. Let me take this as not 1, as 25 from the point 3 comma 4. From this point 3 comma 4 we have to find the equation of the tangent to the circle. First what I have to do is let me write this 25 to the left hand side. So I'm going to get x square plus y square minus 25 is equal to 0. So first I'm going to find the S11 value. S11 is equal to, substitute this point P coordinates in the given expression. So we are going to get 3 square plus 4 square minus 25. Actually 3 square value is 9, 4 square value is 16. So 9 plus 16, that will be 25. 25 minus 25, 0. So I got the S11 is equal to 0. So from this I can say that point lies on the uh, circle. Point lies on the circle. Whenever the point lies on the circle, I can say that equation of tangent is S1 is equal to 0. So I'm going to write the S1 is equal to 0 for this circle equation. So x square can be written as x into x1 plus y square can be written as y into y1 minus 25 is equal to 0. So now in the place of x1 and y1, I'm going to substitute 3 comma 4 in the place of x1 and y1. So if I substitute 3, so x times of 3 plus y times of 4 minus 25 is equal to 0. So this will be 3x plus 4y minus 25 is equal to 0. This is the equation of that tangent. Only one tangent is possible whenever the point lies on the circle. Okay. And I'm giving one question as the homework. Okay. Find the equation of the tangent to the circle x square plus y square is equal to 25 from the point P 1 comma 1. Okay. So find the equation of the tangent. So if it is possible. Okay. So that's it for this video. In this video, what we have discussed is equation of tangents for the various cases of the points given to the circle. So the point lies outside the circle. So we can draw two tangents outside the circle. Uh, uh, Two tangents through a given point which lies outside the circle. So we have discussed the pair of equation of tangents, that is s1 square is equal to s into s11. So we can find the equation of tangents using the condition radius is equal to distance from the center of the circle to the straight line. So we have discussed whether both the procedures will give the same answer or not. So if you and then we have find the length of the tangent. So we have understood what is the length of tangent. So length of tangent is distance from the given point and the point of contact. Okay. And whenever the point lies on the circle, so the equation only we are going to get only one tangent equation. So that tangent equation is s1 is equal to 0. And whenever the point lies inside the circle, so we cannot draw any tangent through given point which is inside the circle, so there is no tangent possible. Okay. So that's it for this video. I hope you have understood very well. Thank you very much.